Hi guys, welcome back to this IMONST series. In this video, we'll be talking about problem 6 to 9 in junior. Actually, I've kind of a bit changed my mind because I want my videos to be like short, like you guys can watch the entirety of it. And then quick note that from this section onwards, so there'll be like 15 questions where like the junior and senior questions are exact copies. So I'm not gonna make like say senior questions 1 to 15 because they're like a literal 1-to-1 correspondence with the junior problem 6 to 20, so there's like no need for duplicating, right? So I'll just include both junior and senior over here. So for juniors, this would be problem 6 to 9, and for seniors, this will be problem 1 to 4. As you can see here, problem 6 here states, find the positive integer n that satisfies the equation 4 to the power of 1 times 4 to the power of 2 times all the way up to 4 to the power of 100 equals to sum n to the power of 2 on 2020. So as you can see here, so the base here are a few fundamentals on indices. So let me kind of fundamentals on indices. Okay, so something like this. So if we want to say n to the power of a times n to the power of b, this would be n to the power of a plus b. Okay, so for you, this for normally this would be multiplication, but in index this would be addition. And for like this, so for n to the power of a, this times itself b times, this would be equal to n to the power of b times itself a times, which is equal to n to the power of ab, so a times b, something like this. Okay, so these two things you need to know to solve this problem. Okay, as you can see here, so 4 to the power of 1 times all the way up to 4 to the power of 100 would be equal to 4 to the power of 1 plus 2 plus 3 plus all the way to 100. So you might be asking, wow, such a big number, how am I going to solve it? Here's a small trick. So for any number n, so if you want to say 1 plus 2 plus until n, you can count it as n times n plus 1 divided by 2. You might ask how? So let me show you. So for this one, we'll just write the same thing again. So this is actually discovered by Gauss. You can find his story somewhere else on the internet. So 1 plus 2 plus all the way to n, right? We'll just write the same thing, but back in reverse. So n minus 1 all the way until 1, right? So plus plus. So as you can see here, this one will give us n plus 1. This one also n plus 1. All of these are n plus 1s. Even till the last term, it's an n plus 1. So how many n plus 1s are there here? So n times n plus 1, right? But since this thing is duplicated, as we write it all over again, we just need a half of it, right? So we just divide it by 2. And this is how we get our thing. So 4 to the power of 1 plus 2 plus 3 plus until 100 would be equal to 4 to the power of 100 times 101 divided by 2. Take your calculator or something, don't use it actually. 4 to the power of 5050. So 5050 and some, where is the 2020? And 2020. So if we want 4 to the power of 5050 equals to n to the power of 2020. That's, as you can see here, we know that 4 is 2 to the power of 2, right? 2 squared. So we can take this 2 to the power of 2. So this thing to the power of 5050, which is equals to 2 to the power of 10100. An astronomical number that you might never need to use in real life, but for this problem we need it. So 2 to the power of 10100 is equal to, we can find a 2020 inside here, right? So we can just 2 to the power of 5 times 2020, right? So what we do is 2 to the power of 5, this thing itself, to the power of 2020. So what we need to do in the end is just to find 2 to the power of 5, which is 2 multiplied by itself 5 times, which is equal to 32 to the power of 2020. So our positive integer n over here would be 32, as you might expect. I think this might be moderate difficulty. So of course you need the indice knowledge to solve this problem. Now let's move on to question 7. So we have a sequence of 0 over 60, 1 over 59, blah blah blah, until 50 over 1. And we are asked how many of these fractions are integers. So the first thing I want all of you to know that is the numerator and denominator for all of these fractions add up to become a constant, namely 60. So 0 plus 60 is 60, 1 plus 59 is 60, 2 plus 58 is 60, all the way to 57 plus 3 is still 60. All of these have a sum of 60. So we can represent something like 60 minus n over n. You might be asking why not n over 60 minus n. I don't know. This is like a personal preference. So we have this, right? So the numerator and denominator add up to be 60. And then this thing could be simplified into 60 over n minus n over n, which is equals to 1. So if this thing is an integer, then we would want 60 over n to be an integer, right? Because you plus 1 it. If an integer plus 1 is still an integer. So we want 60 over n to be an integer. We want n to be a factor of 60. A factor of 60 means that n can divide 60 into equal parts, which are all whole numbers. So let's kind of list out the factors of 60. I think the most traditional way one can find the factors of 60 is like making pairs of like, oh, 60 equals 1 times 60. I think you guys are taught this at school. I'm not sure. Maybe leave a comment down below. So 1 times 60, and then we have 2 times 30, and then we have 3 times 20, and then we will have 4 times 15, 5 times 12, and then 6 times 10. And I think that's it. So there are like 12 of them. So among these 60, 15, so there are 60 fractions. So there are like 12 of them that are integers. So our answer is 12. But then again, if you do not know, we can kind of like factorize 60 into something like this. 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 1. So this one, so if you want to find the number of factors that 60 has, you take the power of each of these. So we add it by 1. So 2 plus 1. Then we have 1 plus 1 over here. Then this one is also 1 plus 1. So you multiply all of these together, you will also get 12. So if you know how to speak Chinese, I actually made a video about this like a year ago when we were in lockdown. So I'll put something like this. I'll put this thing over here on the right hand corner. You guys can go and watch it. But in the end, this question is solved. What you want to do is to find the number of factors of 60, and then you would get your answer to be 12. Okay? So this is problem 7 solved, sorry. Okay. So we have problem 8 here. The flag of Malaysia consists of a blue rectangle at the upper left corner and 14 stripes with equal thickness, colored alternately red and white. The width of the blue rectangle is half the width of the flag. If a Malaysian flag has an area of 140 centimeters square, determine the area of the flag in cm squared that is colored red. So as you can see here, the width, meaning this one, is half of the width of the flag. And you can see here, we have 14 stripes, like 4 short red stripes, 3, okay, so 4 short red stripes, 4 short white stripes, 3 long red stripes, again, this one. Then we also have 3, 3 long white stripes. Actually, the limit should be somewhere here, but since the background merges perfectly, okay? So 3 long white stripes. So as you can see, the area of the red stripes, so the area of color red, so red area, is basically the same as the white area. So how do we find the red area? So what we do is the 140, then we minus the blue area, right? We divide it by 2, because since 140 minus the blue area will give us the red plus white area, and then we know these two are equal. We divide by 2, we will get one red area, as you can see here. Okay, so we want to see. So if we give me a moment. Okay, so we have 8 stripes here, and then we have 6 stripes here. So the breadth of this blue area is 4/7 of the breadth of the normal flag, right? of flag. So the area, no, the blue area, as you can see here, the blue area, since we know that the width is half, so the width of the flag, so half width times 4/7 of the breadth, it will give us 2/7 of the whole flag area. Since rectangles, you just multiply width and breadth to get it. So 2/7 times 140, we would get 40 cm squared as our blue area. And then, so 140 minus 40 cm squared. And then we divide by 2, we would get 50 cm squared, which is our red area. So determine the area of the flag in cm squared, that's color red. So you just answer 50. You don't need to add in the cm squared, okay? Yeah, so this is how we solve question 8. If there's anything that I've not explained clear enough, you can write to me in the comments below also. And now let's look at our final question of the video. This is a classic actually. I don't know, this might be satire, but I think this is just ripping off classic problems. Okay, so in a flower garden, 99% of flowers are roses and the rest are lilies. The gardener wants to decrease the percentage of roses to 98% by discarding some roses. The amount of roses he needs to discard is k% of all the flowers. Find k. Note that in this context, the number of lilies is constant. Okay, so it doesn't change. So let's kind of do it. So let's kind of do this whole thing. I don't know. This is like a more Singaporean way, I guess, as they show it online. Okay, so 1%, let's denote by 1. So let's assume there are 100 flowers, and then there's 1% lily, right? So the rest of the 99 flowers are roses, right? So the number of lilies stays the same, and then we want the percentage of roses to be 98%. So 1. So if 1 is 2%, if 1 corresponds to 2%, then 100% would be 1 times 50, which is 50 in this new system. So 98% would be 49, would correspond to 49. So in this new system, it would be 49. So normally, people will be thinking, oh, 98% to 99% to 98%, right? So this is like a decrease by 1%, right? So you just need to throw one flower. But no, you can see here that it actually decreases by a lot. So as you can see here, originally we have 99 roses, right? Then after the purge, after the elimination of roses, we have 49 roses left. So how many roses have we thrown away? Obviously 50. But the amount of roses here discarded, so 50 out of 100, is k% of all the flowers. So 50% 50 over 100 is obviously we can convert it to 50%. So this is why I chose 100 flowers in the first place. So yeah, this is kind of a short video, but I also want to show you that in this specific problem, don't be easily fooled by the numbers that they give you. So that kind of like do a bit of deeper research to find out the truth, I guess. Yeah, something like that. So just don't rely on your instincts in doing math problems. Okay? But of course, as you do more of these competition problems, you might get used to some things, and then you see some questions appearing in competitions like, oh, this is cliche or something like that. Of course, hopefully you would attain that level. I have yet to be honest. So this is today's video. In the next video, we'll be discussing junior 10 to 13. Then for seniors, it'll be 5 to 8. Okay? So see you guys in the next video. This is quite a lengthy one also. I'm gonna decrease the length of my videos.